Okay, hi everyone. Thanks for the introduction, Menu. So the presentation I do or will do today is mainly introduction to concepts that I used in this study that I'm presenting, and then a few results and stuff that I did, just to give you a bit of background, because I know not all of you are familiar with eye tracking or subtitles in general or cognitive theory. So I'll just give a broad overview of each of those, and then just discuss this study that I did, which relates to the topic of this presentation. So, as I mentioned, an overview. So, how does digital humanities and subtitles fit together? Some subtitle benefits and characteristics and measurements of eye tracking, then of cognitive load, and then some results from the study that I did. Okay, so just about myself. I'm a research.
Sorry to interrupt, Gordon. I'm not sure if you're thinking of sharing your screen. We don't see your screen yet.
Oh, it's opened up in here on my side.
Okay.
Okay, let's try that again.
Yes, that looks better. Thanks.
Okay, so there's an overview, just a bit about subtitles, a bit about eye tracking, a bit about cognitive load and measurements of cognitive load, and then the results from the study that I mentioned as the topic of discussion. So just a bit about myself. I'm a research technologist at the School of Languages on the Van der Bijl Park campus at Northwest University. I'm also in charge of the eye tracking lab, helping setting up, collecting, analyzing eye tracking data. And then my PhD thesis was measuring the impact of cognitive load in educational context. So digital humanities then forms a bridge between the traditional practices of research and opportunities afforded by technology, providing scholars with new ways to look at old problems and methods, tools, and frameworks to support in our awareness. So what subtitles do is they are have a long history in the field of audiovisual aids, which includes videos. There was in the early 1900s, there were museum schools that went from school to school, presenting videos of stuff, doing pictures, and even some shows on specific topics of interest. So subtitles generally converts the speech into text on the screen, and it provides access to information in any language group, depending on the translation that you do with within the subtitles. So some characteristics about subtitles. So there are generally three types of subtitles: bimodal or intralingual, which is the dialogue and the subtitles are the same language. Then standard or interlingual, those where the dialogue is English, for instance, and the subtitles are in a mother tongue. And then the reverse is the reverse of the standard, which is there's a mother tongue dialogue and then English subtitles. So subtitles are generally used in the entertainment industry, and more often than not, they are reverse subtitles. But recently, subtitles have also been used in an educational context for online learning, e-learning, and such. Okay, so some background about subtitles. So it's text that's in sync with the dialogue of a video. So this is also different from reading static text like book, newspapers, and such, and which also means that the research specific for static text cannot be applied to subtitle research. The main reason is that it is only visible, the text itself, for a short period of time. They call it dynamic text, which means that usually word count and reading ease and stuff like that, that's usually used for static text, cannot be applied to subtitles. So you need to find new ways in order to process subtitle engagement and so on. Then there are two ways of creating subtitles: standardized and automatic. And then there's a study lab project that launched recently about automatic subtitles of the president's speeches. I've looked at that and it looks quite good, but some general automatic subtitling like those on YouTube, especially for non-English languages, are quite problematic. So there's a problem there. I'll address that problem also in my presentation. Okay, and then the other problem with subtitles is that it must compete with the share of cognitive resources with other audio, with the audio and the visual components of the video. So generally, the optimal speed for subtitles is 120 words per minute. That's around 10 to 20 characters per second. The maximum on-screen visibility is 6 seconds. So that's usually for 2-line subtitles. 1-line subtitles, you can halve that, 2 to 3 seconds. And each subtitle line has about 37 characters displayed that include spaces and punctuation. So then the benefits of subtitles. So mainly research for subtitles in the educational context are done in 3 major groups: language acquisition, which is also can be accidental language acquisition from subtitles, vocabulary learning, and comprehension or retention of information, which is the main focus of my study. So subtitles can also be translated to any other language, and it's more cost effective, although a little bit more time consuming than other language transfer methods like dubbing or voiceovers or re-speaking. So subtitles also help with accessibility to information for lesser known languages, and is mostly used on e-learning platforms and environments. I think this is a video, yeah. So if you present people with video, cannot play video. Okay. I'll go to the next slide. So if you just go to the previous slide. So if you, okay, I'll also explain it. So the problem is if you present somebody with a subtitled video, which in this case should have been this, you don't know if they process the subtitles at all. The only way you can really tell is by giving them a comprehension test to see if the content they had to master, they indeed did. So to measure subtitles, we use an eye tracker. So this will be in the next slide. So as I said, mainly subtitle processing is measured through comprehension, but there are other techniques like eye tracking. So it records the eye movement on a video, so you can see where the attention of the student was, how much time they spent on specific areas on the screen, and also if they read the subtitles or not. So these are screenshots from the study that I did. With the eye tracking, you can also identify areas of interest. That's the blocks around. So we identified the lecture, as he's the one doing the talking, and then the subtitled area. And as you can see, in both of these cases, there is a difference in where the students looked. So to just give an overview, eye tracking measures come in two. Eye tracking is measured in two ways. The first is fixations, which in these screen captures are the circles. The bigger the circle, the longer the fixation duration, so the longer attention or time they spend on a specific area. This is known as the eye-mind hypothesis, which means that where you look, that's the information that you're processing. Then saccades, which are the lines. Those are the movement of the line of the eyes between two focus points. This is typically used for reading research to see the number of words skipped or such. And then scan path, which is the combination of fixations and saccades, or the dots and lines, and that is directional movement. So for instance, if you are analyzing a website, the usability of a website, you can use the scan path directions to see in what order did the participant look at specific aspects of the website. Okay, so then the eye tracking measurements. This is usually based on the attention to objects that can be measured. So if you want to see how many times a participant looked at an object, you use fixation count. So how many times is fixation count? How long is the mean fixation duration? So how big or how small the circles are. How a person moved their attention to and from objects, that's the scan path. How long did the person look at the object is the same as mean fixation duration, but dwell time is dwelling in that area of interest that moving inside that area of interest that you want. For instance, in the subtitle area, the dwell time is calculated the first time the eyes go into that area and the last time, or the last fixation before it leaves that area. Then you can also get a transition matrix, which says how many times the participant looked from one area of interest to the other and vice versa. You can calculate reading speeds or words per minute. You can have pupil dilation. So the bigger the pupil, the more cognitive strain on the brain there is. It means the more attention there was. And blink rate, you can also use blink rate, so less blinks equals more cognitive strain on the brain. So more information processing or strain on the brain. So specific eye tracking research. So there are three different types. So the one is assistive technology. So that's mainly for people with complex physical disabilities. They can't move their hands, their arms, their feet, and such. So the screen, on a screen, there's an interface that tracks the person's eyes, and then they can click and move and type with their eyes without moving their hands and feet. Then there's also research that focuses on the development of hardware and software for eye trackers. And then the academic research, which I'm mostly part of, focuses on reading, so static reading of texts, subtitle reading, editing processes, translation processes between the source text and the target text, the usability of interfaces, testing comprehension, where did they look, get information from, and also aspects of cognitive theory. So there are four main paradigms of eye tracking. So visual search, searching for information, looking for doing specific tasks, then reading, so static or dynamic, then scene perception, which look at how people interact with a scene. Well, it could be a painting, or in this case, the picture there with the lungs is an expert versus a novice, or intermediate versus a novice at the far right, when they diagnose specific lung ailments. And then usability, that is, for instance, in an interactive study guide or a website, or that to see where people look, what attracts their attention, and so on. So I've talked about a little bit about cognitive load. So here's just a brief overview. Cognitive load is mainly concerned with the learning of complex cognitive tasks and the relationship between the working memory, which does the processing, and the long-term memory, and the effect of their relationship on learning and problem solving. So generally, there are two types of memory. There's the working memory that processes all the information you get from your eyes and your ears, so visual and audio information. And then the long-term memory, which is the repository of all the information, all the skills, everything that you've learned in your life is stored in the long-term memory. And the more the process of specific information is repeated in the working memory, that information is then stored in the long-term memory. So certain aspects of tasks contribute to cognitive load. This is usually known as causal factors of cognitive load. So there are two types. The first is intrinsic cognitive load. So that has to do with the strain on the brain by interacting with a task by an individual. This is really a result of the difficulty of the task. And then extraneous cognitive load, which is due to the presentation format of the task. So how is it presented? Is it presented on the screen? Is it presented on paper? All those type of stuff. Then specific measurements of cognitive load. There are generally 4 types. So subjective or self-reported rating scales. So these are questionnaires that people fill in. You can get standardized questionnaires which associated with the type of cognitive load that may appear, and then the participant self-evaluates their experienced cognitive load for certain aspects of the task. Then physiological measurements are, in this case, eye tracking, heart rate monitors, skin conductivity, anything to do with the human body. Then psychological measurements are EEGs, fMRIs, so all brain activity related measurements. And then dual task performance has to do with presenting or giving somebody a primary task, and while they're doing a primary task, you get them a secondary task to sort of divide their attention and see if that influences their performance based on error rates. So for my study, I used the physiological eye tracking measures, which is fixation count, so how many times they looked at a specific object or area of interest, and then average fixation duration, which is the time spent in that object that they looked at. So now to the study that I did. So I'm measuring the effect of subtitles on cognitive load. So the problem with subtitles and the effect of subtitles on cognitive load is that there are inconclusive evidence of the effect of subtitles on cognitive load. So here is a summary of some of the studies that I gathered. These are both in native language and foreign language studies, and the effect is either positive, negative, or neutral. So the band that my research is focusing on is on the right side, the bottom band, which focuses on foreign language and comprehension or retention. So as you can see here, nobody really knows what the effect of subtitles are on cognitive load due to this variability in results across many studies. Then, so for my experiment, I used 23 participants. They were non-native English speakers. I divided them into 4 groups. Each group watched 4 videos in 4 different presentation modes. So those that are on the right, audio only, which is just the sound, then audio and video, which is a normal video, and then video with standardized subtitles. I'll explain what standardized subtitles are, and then automatic subtitles. These were presented in randomized order, and they completed a self-perceived cognitive load questionnaire afterwards, and also comprehension test on the content of the video. Okay, so as I said, the material was self-reported questionnaire and comprehension test. The subtitles were English, along with the dialogue, which is also English. So standardized subtitles are subtitles that are generated through specific guidelines. We used BBC's subtitle guidelines, which says no longer than 6 seconds per subtitle. Each subtitle line is 37 characters. All those characteristics that I gave in the earlier, those are standardized, and you have to create those subtitles manually. Then automatically generated is usually done by a speech-to-text generator, which syncs up, in most cases, with the dialogue of the video. These are usually time-coded, so when the subtitles appear, when they don't, which can be problematic for automatic generated subtitles. So my research questions were, how does cognitive load affected by different presentation modes? So with audio, video, and so on. And then what effect does subtitles have on cognitive load? So the first part of the results were there's no significant difference between comprehension, intrinsic cognitive load, or extraneous cognitive load. This is between all presentation modes. So between the video, the audio, and the 2 subtitle modes, there were no significant difference. But there was a significance in the extraneous cognitive load that has to do with the format of presentation between the 2 subtitle presentation modes, which is strange because according to the definition of extraneous cognitive load, both these presentation modes are similar in terms of format of presentation. They are both videos with subtitles on them. So this higher cognitive load also affected the comprehension, where the automatic the participants that watched the automatic subtitled videos scored 10% less for the comprehension test of the videos on average than those that watched the standardized subtitled videos. So what could be the cause? Generally, it has to do with the construction or the structuring of the subtitles. So if you look at, these are the similarities. The number of subtitles per video were more or less the same on average between the videos. The average number of words per subtitle were more or less the same. No significant difference there. Average speed of the subtitles, that was the same. Number of skipped subtitles in the videos, more or less the same. So what could be attributing to a higher cognitive load? So here is an outline or a graph stipulating the characters per second speed for the automatic subtitles, grouped according to intersections of 5 characters per second. So the green represents the automatic subtitles, and the blue the standardized. So usually the sweet spot or sweet area of presentation is between 10 and 20 characters per second, or 120 words per minute, as mentioned earlier. So the possible problem here is that for the automatic subtitles, there are a higher number of lower characters per second subtitles, and also a higher number of more than 20 characters per second subtitles for automatic subtitles. This would better be demonstrated. So this means that for the automatic subtitles, in more of the slower subtitles and more of the higher subtitles were present, which may have caused the effect of cognitive load on the participants. The other thing is, so here I've plotted all of the speeds of all of the subtitles for automatic and standardized. The red line, and if you can see the red line in the middle there, is where the average speed of the subtitles were for both groups or both types of subtitles. Then if we put a block over the sweet spot, if I can put it, the accepted presentation speed of subtitles, you'll see that there are more green spikes on the lower half and on the top half, and then blue spikes. What this indicates is not that there variation in speed, but there are more variation in speed between consecutive subtitles. So in a standardized subtitle, you control the speed of which the subtitles are presented. This may be in sync with the dialogue, but in some cases, you have more time to present a subtitle for more words than the dialogue. Then the dialogue is long. But with automatic subtitles, you, especially with speech to text, you associate the speech with the text directly, which means there is more variation between consecutive subtitle presentation or visibility on the screen, which I think caused the extra cognitive load for the automatic subtitles. So just to conclude then, subtitles can help with accessibility of information, also accessibility of information in other languages. Subtitles have no significant influence on comprehension or cognitive load compared to other presentation formats of the same content. However, the higher extraneous cognitive load for the automatic subtitles had a significant lower significant effect on lower comprehension scores. So automated subtitles, although more cost-effective to produce, have negative consequences in the generation and various other aspects of subtitles that need to be controlled for. Whereas for standardized subtitles, although more costly and more time-consuming, you have more control over the presentation speed of subtitles and seems to be more effective for information accessibility. Thank you.
Thank you very much for an interesting presentation. I do see there are a few questions in the chat. So if other people also have questions, then just write it there. So the first one by Sasha, how is the reading speed measured?
So the reading speed for the subtitles we had to do manually because the subtitles are burned onto the video. So usually with normal or subtitle reading, you have one fixation per word in a subtitle. So we can generally calculate based on the number of fixations that and the number of characters or words in a subtitle, how fast a student reads.
Sorry, so I'm now trying to think what that actually means. So you have fixation points on each of the words in the subtitles, but I think while reading the subtitle, you often skip words as well, right? Because so function words, I guess you could kind of skip. Do you then count these as well, or do you just count fixation points?
Yeah, it sometimes that is true, but because most of the time the subtitles are too fast. I see. Okay, well, let me explain it better. So first, there is measurement of. Okay, so the reading speed for subtitles is different from the reading speed for static text. For static text, you have a sentence or a paragraph that you know how much words, and you can measure how long the person took for reading a specific text in a minute. And you know specifically how much words there are in that text. For subtitles, we have a formula that calculates how much and how many of the subtitles were calculated. So it looks at the number of forward movement or forward fixations called unique fixations and the mean words associated with that subtitle. It's called the reading index for dynamic text. So it gives a score between 0 and 1 to indicate to what degree were the subtitles processed, and with that you can also determine how fast the words per minute, depending on the speed.
Okay, wonderful. I hope that answers your question, Sasha. Okay, Tanya also has a question. So do you somehow measure previous experience with subtitles? So experience in quotes. And I think it's more, how people are used to using subtitles, for example.
Yes, what's interesting is we have a colleague in Australia, Macquarie, that did an identical, or more or less identical study than the one that I presented. But they use South Asian participants, which are used to subtitle media, and their automated subtitles had much more grammar problems and language of translation problems than mine did. And they still indicated that there were no significant differences between either the comprehension or the cognitive load between those two subtitles. Whereas for our students in South Africa, we don't have much access to subtitle reading. So for our students, it's much more the slightest variation in presentation or pattern of presentation for subtitles can have a major effect on how they process the subtitles. Hope that answers your question.
Yeah, that's quite interesting. So Tanya says, I would think the cognitive load for someone used to subtitles would be lower than for novices.
Yes, yeah, especially from European countries or South Asian countries, which are used to subtitle reading on a daily basis.
No, exactly. I actually remember seeing a film in Switzerland. I know Tanya's from Switzerland, where there was multilingual subtitles. So you actually needed to get the right line
Find your
subtitles
place
as well. And even though I'm quite used to using subtitles, that was actually something that I had to get used to. So I need to find the right
line to read.
Yeah. So that is a bit of experience, I guess. I actually had a question that's kind of related to that, and I do see that Masi also has a question, but I'll quickly jump in here. So I was actually wondering what other variables might influence this. So I saw that in your experiment, I'm not sure if it was just the image or whether it was in your full experiment, the standardized subtitles actually had a black bar behind the text, and the automatic subtitles didn't. So I was wondering if these kinds of things will also have an influence on.
Yes, it can, but this there are studies that also found that any, if I can say, apart from font size, any other manipulation of the background doesn't have much of an effect on the cognitive load, as you, well, which is counterintuitive, but I think if the subtitles themselves are quite easily visible, the black background might make it more readable, but the speed of the subtitles and the language and the how often you read subtitles may have, I think, a bigger influence on the content load than just being easier to read.
Yeah, that's interesting. So Masi has a question. Can the same methods be applied to check how long children may take to read a word?
Yes, so one of the measurements of eye tracking is mean fixation duration. So if you block out a word on a text, and then it groups all of the measurements for that area in your statistics. So then you can see how long a participant looked at that word before they moved on to the next.
Okay, cool. I was actually wondering about kind of a very simple question, I guess. So I was wondering how precise this eye tracking is. You get these really nice circles, but if I look at part of the screen, I don't see just one dot, right? I see an area of the screen. So I was actually wondering how that would work. Also with reading.
Yeah.
Do you see just a full word, or?
For the subtitles, the thing is, those areas of interest are done post-experiment. So you have to manually go and drag the AOIs on the video and then switch the visibility on and off. So doing that, because the subtitles are burned onto the video or embedded in the video. So you can't, it will take you years if you want to do it word for word. The eye tracking software that we use does that for PDFs or text. So it automatically makes areas of interest for paragraphs, for words, even characters if you want.
Okay, that will help out. But I was more thinking not necessarily about the identification of what word you look at, but just in general. So if I look at the screen, so I think the eye tracking assumes that I'm looking at one specific point on the screen, but I think at the same time I see an area around that point. So how does that work?
So each individual participant's eyes are calibrated beforehand, and there are specific areas on the screen that are identified where you check how accurate the synchronizing of your eyes with the eye tracker is. So that's usually less than 0.5 of a degree from where you look. Then it only looks at so it measures the distance from the pupil and the corner, because it uses, I'm going very technical now, but so I know what you mean by the fovea space between or around, so words before and after a specific word. But to be as precise as possible, it takes the reflection of an infrared light and the pupil and position to determine where you are looking, and it takes the average of the two eyes to a specific point. So the big dots and small dots are just your attention focusing there. The raw data is quite literally a dot, if I could put it. So just a coordinate on the video where you looked, or the average place that you looked. There are studies that were done where they masked out certain words or characters before and after, and to see if people notice it.
Yeah, cool. Thanks. So I'm not sure if there are any other questions. I don't see anything in the chat. Oh, there is. Friedel has a question. What is the relative roles of fixation count versus fixation duration versus pupil dilation?
Okay, so fixation count helps you to determine sort of the importance of a specific object. So how many times they look at it. In reading, fixation count means that you can differentiate between an expert reader and a novice reader, where novice readers will look at each word individually and expert readers will skip words. So that's a way to determine those. Fixation duration has to do with how long one focus point was on a specific area. So that just gives you an indication of how long a person needed to look at something to process it completely or comprehend it completely. And then pupil dilation, we rarely use. The thing is, pupil dilation is quite sensitive to fluctuations in light. So you have to control for, even as if you do it on a screen, which eye tracking studies normally are, between darkest pages and lighted pages, if you do a website or something like that, pupil dilation will be influenced by the fluctuation in the light, or some people are more prone to stress or stuff like that, emotional things that will also influence the pupil dilation. So it's not as accurate or precise. So what they usually do is they have a baseline where somebody just looks at the gray screen and measures their pupil dilation, and then over the video they can determine the fluctuation, either bigger or smaller, from that baseline for pupil dilation. Hope that answers your question.
Does that answer your question, Friedel?
Thank you. Yes, I'm more trying to see if, in trying to measure cognitive load, to what extent, or like, how do we build this puzzle if we have to, for example, combine information on fixation count versus fixation duration, because both somehow seem to indicate larger cognitive load in higher quantities, but their relationship to each other, for me, is a mystery.
Okay, so fixation count not as much for cognitive load, fixation duration more, because if you remember back to the eye-mind hypothesis, so how long or where you look, that is what you are processing. And then pupil dilation, although being not used frequently, the bigger the pupil, the more information you take into your eyes, and the more difficult, or you can say it's difficulty of the task, is measured by the opening and closing of the pupil dilation. I don't know if that's a better explanation. Okay.
Great, thanks. I'm not sure if any other people still have questions. I actually still had one question left. So I think you focus now only on English, right? So the
Yes.
audio and the subtitles were in English.
Yes.
But I think in South Africa, kind of a multilingual situation might be interesting.
Yes.
So do you have any plans on working
so
on that?
we have done. There's a master student that I've done on Setswana. There is a PhD student that focuses on Sepedi reading, not specifically subtitling. We have published a paper on Sesotho L1 versus Sesotho L2 readers. And what was interesting is due to the dynamic nature of the subtitles, their reading proficiency for Sesotho, so our first language or native language speakers of Sesotho could not keep up with the Sesotho text or reading. So their proficiency for reading, those that we tested, they read halfway through the first two subtitles and then looked at the lectures page, the rest of the video, which was quite interesting.
Do you have any idea why that is?
Sorry, Manu, can you repeat that again?
So do you have any idea why that is? That they only read half?
So the one thing is we didn't ask them for how long they had Sesotho at school. So it could have been that they only had to grade 6 or grade 7. So their proficiency level for Sesotho was not on standard with what we assumed was the appropriate reading speed for the subtitle, the Sesotho subtitles.
Mm-hmm.
Yeah. Because I don't know if you know Susan from Roy, but she works with multilingualism, and most of the time, the her participants overemphasize their proficiency in a language when they are. So if they say they are very good at writing and reading Sesotho, for instance, they score lower on reading tests for Sesotho than for English. But they still identify themselves as Sesotho mother tongue readers or speakers.
So there are kind of more perhaps cultural aspects that
yes.
This. Yeah. Interesting. Okay, I'm not sure if there are any more questions. We're also nearing the end of the colloquium, but if somebody still has a quick question, they're quite happy to ask. Fido?
Yes, while there's some time, Gordon, it might take too long to answer, then feel free to postpone this for another time. I'm just trying to work out how did you estimate the influence of variables in measuring cognitive load. The table on that slide suggested that it was linear regression. Is that right?
Yes. That was actually a linear mixed effect modeling. And that specific graph was on mean fixation duration as a measurement of cognitive load.
Maybe I don't remember the contents of the slide well, but I got the impression that the p-values were not well, I tried to work out why you said that
okay. So
I forget the extraneous values were there was some value there.
Yeah, so the table that I put there was for between all the presentation modes, but there you still saw that the ECL values were. I can maybe show it again. So basically, the results that I gave, there's just to show that there was significant difference between or a higher ECL for automatic subtitles than for standardized subtitles when compared to all the other presentation formats or presentation modes.
Okay, that was the first column in the table, right?
Yes. So the other one that I didn't put up, but I did a linear mix effect modeling also for only based on the two subtitled categories, and taking into account so the comprehension as well as the ECL values, and those show significant differences in the p-values.
Okay, thank you.
Okay.
Great, thank you again, Gordon. I think we're kind of at the end of the colloquium, but thanks for the presentation. I really enjoyed it. It's a completely different topic from what we've had so far at the Digital Humanities Colloquia. So this is kind of a fresh, new methodology, new techniques. Yeah, thanks. And I'll stop the recording here.